Welcome everyone to our last webinar in the Getting Practical with MBSE presentations in June, Ensuring Design Integrity through Executable Behavior Architectures and Parametric Constraint Analysis presented by Ron Kratzke. My name is Donna Long and I will be your host during today's webinar. Our lead presenter today is Ron Kratzke, Principal Systems Engineer at Vitek. He is a retired United States Navy officer with over 20 years of engineering experience managing nuclear engineering and combat systems on surface ships. Ron was introduced to the systems engineering practice near the end of his naval career while conducting mission and capability analysis for the Navy staff. For the last 15 years, he has worked as a systems engineer supporting advanced systems development for a number of federal government agencies. He was introduced to CORE in 2007 and utilized CORE to manage system development tasks on 3 different projects in the 5 years before he joined Vitek. He is now a provider of professional services in GENESYS and CORE, as well as a central part of the Vitek training team. Before Ron gets started, I have just a few housekeeping items. We will be answering questions at the end of the webinar. Please send your questions in as soon as you think of them through the question tab on the webinar control panel. Ron will answer as many questions as he can today, but if we do not get to your question, we will reach out to you after the webinar. The webinar is being recorded. If you experience connection problems during the live presentation, a recording will be available within 1 business day. The recording will be published to Vitek's webinar archive located on our website. At the conclusion of this webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you would like to see covered in future webinars. Now I'm going to turn the presentation over to Ron. Welcome and thank you for joining us.
Thank you, Donna. Good afternoon, everyone. As Donna said, today's presentation we're going to talk about executable behavior and parametric analysis. So there's 2 things in systems design that we are often confronted with as systems engineers, that we have to communicate what we want, communicate our desires in the design to other people on the engineering staff. That primarily occurs in this thing called functional architecture analysis and what I'm going to call behavior analysis, and I'll talk a little more about what that means in a moment. And then we have to link this descriptive architecture that we've developed in our system design to the analytical architecture. And if you're familiar with the systems modeling language, that occurs when we do constraint diagrams and parametric block diagrams. And there's a parametric diagram down on the lower right-hand side if you are wondering what those diagrams are. And in GENESYS, we have the ability to not only create those diagrams and link them to the descriptive architecture that we have, but we can also execute those diagrams with a MATLAB solver that we have in GENESYS. So I'm going to go through and I'll show you how that solver works also. On the lower right-hand side of this screen, or on the lower left-hand side, excuse me, of the screen, you'll see an EFFBD diagram, and that shows a functional flow block definition diagram that shows the links or the messages and the items flowing between all of the functions. Now, I'm primarily going to use the EFFBD diagram in my analysis, but I'll also show you how that EFFBD diagram is similar to the systems modeling language activity diagram. So we have done this is the third presentation in this series, and we've talked about how we do requirement analysis, how we do some behavior and architecture analysis through those. And where I'm going to concentrate on in this particular session is I'm going to concentrate heavily on that behavioral analysis gear that you see in the middle, and then I'm going to talk a lot about that physical architecture and how that physical architecture links to this analytical architecture that you'll hear me talk about. So let's talk a little bit first about the functional architecture. So functional architecture, when we think of it, it's normally an understanding of what the system must do. We get that understanding from an enumeration of the functional and performance requirements that the system has to do. And generally, when we talk about a functional architecture, we talk about the decomposition of that architecture, or the aggregation of the architecture from the bottom up, or decomposition from the top down, and we look at how those functions are allocated to the physical components in the architecture. And when we see those, when we look at that functional architecture, we normally see that in a hierarchy diagram and requirements type diagrams. We'll see requirement diagrams that show how the requirements are decomposed, and then how those decomposed functional requirements are then based on or the basis of functions in the architecture. When I talk about behavior architecture, I'm taking that one step further. Yes, it's all that functional architecture, that decomposition, the aggregation, the allocation of those functions. But in the behavior architecture, I'm looking at the control and timing of the functions. Which function do I want to occur first? Does that function send a message or send an item one place or another? Where do those items go to? How do I control the sequencing of my functions? How do I organize the functions? What functions is a customer going to do, and what functions is the system going to do? And so the behavior architecture takes a step further than the functional architecture, and that's why we talk about behavior. And in order to do a behavioral architecture, obviously you've got to be able to do the behavior diagrams, an EFFBD or an activity diagram, or sequence or IDEF0 diagrams. All of those show level of control and timing to one level or another. But we also need to be able to validate those diagrams. And we validate those diagrams in GENESYS through the simulator that's part of the GENESYS package. So I'm going to pause here, and I'm going to go into GENESYS, and we'll talk a bit about this functional or this behavior architecture and the functions and how those things work. So I'm going to switch here out of this into GENESYS. So now you see GENESYS, the GENESYS software, and I'm just going to take. I know that some people are very familiar with GENESYS, but others on the screen on this webinar may or may not be familiar. So I'm just going to take a quick, brief couple of minutes to help orient everybody. So here is a series of projects that I have in my on my GENESYS in my GENESYS repository. And when I open a project here, you'll see the project come open in just a second. So here's the project, and just a quick, brief orientation here. So across the top here, we have our ribbon bars. So once I select something, I can look at different things. The ribbon bars controls what I'm seeing in the rest of the screen. On the side over here on the left-hand side, I have the Project Explorer frame, and I'm in the systems engineering role here on this project, and I can see things like requirements. So I'll just look here briefly. Here I have a set of requirements, and here are the requirements, and then there's up here there is a set of components that are part of my architecture, and here there are a set of functions and some subfolders here in functions that kind of break things up. So if I was to look at the workstation, I know what the workstation does in my architecture. If I know if I want to look at the command center, I can see what the command center does. Okay. So back here on requirements for just a moment. When I select one of these, when I select anything, you'll see the property page come up. The property page is populated with all the information associated with the element that I have selected here. And then, so we have a series of attributes here that help describe this element called the requirement. And then down here I have relationships, so I show that this requirement is related to the rest of the architecture in some way, shape, or form. And then once I have something selected here, I can also look at the Views tab. And once I'm on the Views ribbon bar up here, I can then look at diagrams. In this case, a requirements diagram is right here, and so I can look at this in a requirements diagram format, and you can see the requirements diagram. Okay, so that's a real brief understanding of how these things look on the screen. If you need more information on that, if you go back a couple weeks prior to this, well, it's actually going to be a couple webinars prior to this. We did a webinar that explained some basics here about how to get into into the model and start creating an architecture. So with that said, I'm going to close this particular project, and I'm going to look at a project that I already have open. This is a project that I just put together to do this webinar. So I've added some things in here. If you look here, I'm going to look at this particular thread first to just sort of introduce ourselves to an EFFBD diagram. So if I look at this, I can open an EFFBD diagram. I'll open it up in full screen and center my screen so you can see the complete diagram. So here's a diagram here. We've got a line up here where there's some functionality here. All these things are occurring in parallel. We have some functions here. The functions are shown in this these sand-colored boxes, and then data stores that are flowing between the functions are shown here either in gray or green. And a green box here has a control role. And what this green box tells us is that once this function down here, notify customer of estimated delivery, once that function finishes, it sends a message up here, and this message, if you will, or this data store, is required for this function, receive an estimated schedule, to do its functionality. So this function up here will not be enabled until this particular trigger is received. Okay. Now, so we can put this together. This is something we wanted to do. When I receive an information request, I'm going to go through and do these functions. I'm going to task a collector to go out and get me some information, send it back to me. I'm going to, at the same time, I'm going to notify the customer that I've got this request, and I'll send you this information in X amount of time. And then once I get this information back, I need to add it to my inventory, and then I'm going to provide that product to the customer over here, and we're all finished. Now, many times we take these lines and we'll give them a name, and so one of the things we do here is we'll select this whole bar here, and if I right-click, then I can edit the annotation, and I can call this my system. So I have a system here that's going to do something, and then up here, this is going to be the customer up here, so I can go through and make sure this is what I'm going to allocate to the customer here. It's going to indicate that these functions are being done by the customer. And then down here, I'm going to indicate that some collector, maybe whatever collectors I have, is going to do this information. So I put together this is what I'd like the system to do. Sounds fairly reasonable. But now what I need to do is I need to execute this. I want to validate this. So up here in the top bar, we have a thing called, we have this little button here called the simulator. So when I execute this, I can, well, first I have to open the button here for the simulator. And this is the simulator window here. So just real briefly, if you've never seen this before, here's the simulator bar. This ribbon bar up here allows us to look at, to change things on the simulator when we get it. When we run this, you'll see the actions that are occurring will occur in this area, the main part of the screen, and then down here at the bottom, we have an enumeration of all the things that are occurring in the model. So my active model is right here, and so that's the diagram I have open. So I can go to the simulator here, and I can run the simulator. Now, I purposely created this functional diagram with an error in there, just to show you that many times when you run these things or you create them, you're going to have errors in the model. They can get very long and very lengthy and very complicated. But what the simulator is telling us here is I've got a problem. I can't do something because something isn't working quite right. So what I do here is I can close this, say okay. It'll put up there how far it's got in the model. And I can look at, there's a transcript here, but there's also a listing of blocked events here, okay? And so it shows me here this little listing of what didn't happen. Now, up here in the top here, the way I troubleshoot this is I can look at something called the execution hierarchy, which shows up over here on this side. and I can open this. So this is the branch, here's the parallel, and I can open up what's happening here, and I can see visually things that didn't occur, okay, because they have little red flags in front of them. And then I can read down here and I can say, it gives me some reasons. There's no available trigger for this information request. I never got, something's happening here that I couldn't do. I didn't get this, and because I didn't get this, the collector tasking isn't working, and I never got the estimated delivery schedule either. So it's got to be someplace in the beginning. I know that this is the construct ID is 1, 2, 1 here. So I can go up here and look at where is 1, 2, 1. So 1, 2, 1 is this one right here. So it has to be it has to have something to do with this particular function. Okay. So I can close this. I can either, if you have two monitors here, it helps when you have two monitors here, but I can move this off to the side, or I can close it, or I can minimize it and bring it back up. But if I go in here, I know that right now I can't see the numbers. So the first thing I can do is go over here, and now I can, with nothing selected here, I can change this template here. So instead of having just the name of the things that are on there, I want the number in the name, so I can find this little, whatever function is not working right for me. And did I do that number and name right? I have to, let me go back and refresh this. And renumber this. And you'll see T21 is this one, to make information request. If I open up my model again, it had put the numbers in there for me. So if I look here, T21 and this T24 accept information request. And what's happening here is this information request doesn't have, it's not coming from any place. It has to be provided by the customer in this model. So I can fix that easily by taking this function and edit the outputs for that function. And what I want to pick up is this T2 information request. So I'm going to go in here, look at the items associated here. And if I look at information request, I go down here and grab information request, add it, close. So now I have that in here. So that's a common failure item. We're not bringing that request in from any place. So now that I've done that, I'm going to go back to my simulator here, and I'm going to rerun the simulator and see what happens. So before I do that, I'll make it larger so we can see the whole thing. We might want to flip back and forth between the two screens. And so I'm just going to run the simulator now. I have something else wrong. I knew something else was going to go wrong, but I just wanted to show you another common failure here. So this is a different failure. And what's happening here, it's telling me this collector tasking right here, there's no available trigger for this particular function. It's not getting its trigger. It didn't come in. And I can also show you through the execution hierarchy here. If we look through there, we'll see the similar sort of problem, and here it is. We never get this. We never get to process and collect the data. So if you look here, no available trigger for this one, and that's the construct ID T211 from collector data. So let's look in that part of the model, and you see what happened here is task collector is providing the collector tasking, and then I'm sending the collector data back, but I can't send it back to the same function because that function I can't receive this first. The receiving this trigger is what allows this function to actually execute. So this collector data, when it comes back, needs to go to a different function in my system. So what I really want to do is take collector data and move it to come in over here. So I'm going to select task collector like I did before, and I'm going to edit the trigger that's coming in. So here's the trigger coming in, and I'm going to edit that trigger, and I'm going to remove collector data this time. So now it's no longer coming in, but I want this to actually trigger this add product to inventory. So when the collector data comes back, once I get the data, that would clue me or cue me into adding the product to inventory. So I'm going to select add product to inventory, and I'm going to add a trigger called collector data. So let's just move this over to the side here. Here's collector data. So if I go into all the items for this thread, if I grab collector data, so now I've added this to here. Well, let's try this again. And this time it worked, and I want to pull this over to the side here and kind of show you what's happening here. So what happens here, this particular function make information request executed and send that information over to accept request. So here's accept and format the request, and here's the activity we've done here. This is the collect data is on the bottom line here. So the collector waits around until the collector gets tasking from us. So it's enabled at the very beginning, but it's just waiting. It's in the wait stage to get this message. It does its functionality, we get something back, and then we finish the execution. At the same time that we sent the message for collector tasking, we also got the estimated delivery schedule back here. So one of the things I can do here to help us along here, and I won't do all of them here, but I'll just show you one because we're going to delve into this a little more detail in a moment. But I'm going to open database entities here. And now you can see that what's showing up on my simulator right here is all the functions. So I'm going to go to items, and I want to include this item called information request, just one item for right now. And when I do that, this is that actual item. So the item is being sent from here down to this particular accept and format request. You see, as soon as this function finishes, then the next function, receive estimated schedule, is enabled, but it's waiting to receive the message, the schedule message from our system. And so within the system, we do some more estimation, or we do some more functions over here, and then we would send this back. And if I added estimated delivery schedule here, you'd see estimated delivery schedule here. This is coming out of this function. And then one other thing you could do if I wanted to show this differently is I can change the execution order, or change the order of these things through this edit the order button, and we're going to do that in a few moments. So this is troubleshooting our functional models, making sure that those models actually are validated. They actually do what we wanted them to do, and that there's the functionality is there. Now, this is the EFFBD. Real quickly here before I leave this, let's go back to the to my model here, and I want to show you. This is the thread. This is the activity diagram for this, and so this is the activity diagram. It's synonymous with, or it's the same as the information you see on the EFFBD. It's just shown in a different notation. And you see as I made changes here, those changes actually were reflected in this model as I went through. Okay, same models. This model simulates the same. If I have this open and I go to the simulator, if I run the simulator here on this, we'll get the same results. Okay. So that's basic troubleshooting there. The next model I want to look at is when I run these models, or when I run functionality here, I can also look at the resources. What resources is my system using to actually do its functionality? So I'm going to switch here for a moment to a different model. This model is a model of a hybrid MRAP vehicle. So I've got a hybrid MRAP here. It has a generator which charges the battery. So when the vehicle's running along the ground, the generator's running, it's charging the battery. The battery is losing electrical power, sending energy to the wheels to actually drive, okay? When the vehicle goes downhill or brakes, it has a regenerative braking function to it. And what I want to do is I want to look at a mission profile to see how much gasoline am I going to use up, how much fuel, and how the battery is going to operate in this environment. So I'm going to open up an EFFBD of this, and you'll see this little this diagram that I have here. And what's happening here is I'm going to begin the mission, and as I go on this mission, I have to drive on a flat terrain for a certain amount of time, and I'm doing it in 15-minute time increments. And when I go uphill on this mission, I looked at the mission and I see what I need to do. I'm going to climb uphill, and while I'm doing the climbing uphill, obviously I'm using more battery energy, and the generator is operating. The generator is still operating, but it's not going to be able to charge the battery as fast. And then when I get to the top of the hill, I need to perform silent surveillance. So I want to turn my engine off and just sit there, use the battery power to use my sensors to do this surveillance on an enemy or on the, a piece of terrain. And then when I come back down, I'm going to come down the mountain a different way, and I'm going to cruise downhill all the way back to the base, and I'm going to have the generator running, and I'm going to be running downhill, and I'll have to do some regenerative braking, and then I'll check it in for maintenance. So one thing we might want to be interested in is the battery big enough? Do I have enough fuel in the fuel tank to actually do this? Well, so what I can do here is I can set up resources. So I can look at the level of the fuel tank, how much gasoline is being burned through each of these sessions when the generator is operating. When I'm going on flat terrain, how much energy is being consumed by the vehicle on flat terrain or climbing uphill. And then when I sit there for a while and do the silent surveillance, how long will that work? How long will that be there? So let me just look at the battery for a second, just to show you what this is. I'm switching to the battery level here, and here is the battery. And when you look at the battery here for each of these functions, I set this up so that I know when I'm cruising on flat terrain, I'm consuming 20 or 75 amp hours in every 15-minute increment to cruise on flat terrain. When I'm going uphill, it's a different number. And I've designed this vehicle to have the battery capacity is 900 amp hours, but I'm going to say that I'm only charged to 700 when I start this exercise. I want to see if I'm charged at 700, can I actually go on this exercise, or do I have to wait until it's fully charged? Likewise, the fuel tank, I have a fuel tank that's calibrated to have 25 gallons, or that's designed so I'm only carrying 25 gallons in the tank, but I'm going to start with only 17 gallons. I don't have a full tank of gas. And whenever the generator is running, it's going to consume 1 gallon of gasoline during any of these operating cycles. So those are the design parameters of my design. Can I achieve this mission with only 17 gallons and only charged to 700 amp hours? So I have this set up here. Now, one of the reasons I'm using an EFFBD here, by the way, is because I can only see these resources on an EFFBD. They're not a thing that shows up on an activity diagram. So let me go ahead and execute this, and let's see what that looks like. It takes a little bit longer to execute. I've got more things in there, but it will finish here in a moment. And what's happening here is it's going up by 15 because these are 15-minute increments that it's cycling through and doing the calculations. And so when I look at this now, so this is my model. So I started out here. I just begin the mission, which takes me 15 minutes to get the truck ready to go. And here I'm traveling out on flat terrain, so I'm doing this for an hour on flat terrain. And I have to climb uphill, and if you count here, there's an hour and a half going uphill. And you see how the This is the fuel tank, and the reserves are going down, 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 down. And here's the battery, right? The battery gets this on flat terrain. I'm actually gaining energy in the battery. But when I start going uphill, I can't keep up with just the generator, so I'm going, this goes off. So now when I start here in my surveillance, I am slowly depleting the battery. And when I leave, I start the engine and I go downhill to get home, and this is what happens. So we may have a minimum, some other parameters that say I can't go below a certain percent on my battery in silent surveillance, so I have the ability to start my engine again and get going. So in this case here, I've depleted it down, and I only have 165 amp hours. That's the magnitude there. At the end of the mission, when I come back, I only have a reserve of 1 gallon left in the gas tank. So this operational profile may not be satisfactory. Maybe I have to have more gas in there. Maybe I have to, it would cause me to look at the design and increase the capacity of the fuel tank, or it might say if this is the general operational profile of this vehicle, I really need to have more reserve battery here, and I really want, instead of a 900 amp hour battery, I want to put a 1200 amp hour battery and make an operational requirement that says whenever I go out on this mission, I have to have at least 900 amp hours stored in the battery before I leave. And down here is the whole transcript, which will allow you to walk through what's being done. And here it says consumed 75 from the battery, consumed 1 for the fuel tank, produced 100 to the battery, et cetera, et cetera. Okay. So that's how we can use resources to look at our system and how our system is functioning. Does it meet all of its requirements? Now, the last thing I want to show you here in functional architecture, and then we'll go on to something new, is I want to go back to my prior model, and I want to look at links. Okay. So the other thing I can actually model in my architecture is our links. So if I look at this CFFBD that I have here, so this one here shows me a ground station and a satellite. So what I have here is I have this ground station, and I have these messages and information that goes back and forth between the ground station and the satellite. Okay, and so for each of these messages, when I do this, I task a collector. He's going to receive the tasking, process the order, give me a confirmation. When he actually obtains his data, he's going to send that back to me. And once I get the data, I'm going to check it and tell the satellite that I've confirmed I have good data and release that tasking order. So if you look here, one of the things we have on any item is the ability to set a size. So here I have a size of 150 kilobytes. So this message going up to the satellite is 150 kilobytes. Okay. Now, when I look at this, I'm going to send that message on some physical medium on this link. So if I look here and look at the link that I'm using for satellite communication, I have this link, and this link is designed to send 250 kilobytes per second. Well, that sounds reasonable because I have a message that's pretty small, and it's going across this that particular link. So in my simulator, I can look at simulating this. Now, when I simulate this and I have a link set up and I have all the attributes and values for the link, I look at my model here and I say, wow, it is taking a long time for me to receive this information. Let me just show you what I mean here. If I go to database entities here, and these are those entities that I showed you before. This time I'm going to go to links, and I'm going to show that satellite communication link. And you see here, this is the message that's going up. This is the confirmation message coming down. It's just a small, I got it. But when I'm trying to send back the data, the link is taking an inordinate amount of time to do that. And the reason it's taking so long is because it probably has to do something with this with this particular message size. And if I look on resources here, excuse me, on items here, and I show the imagery data, see here's the function that started it, obtain the imagery data, and it's taking from here to here for this message, for the complete message to actually be received in my system. Okay. If I change the order here to make this a little bit easier to understand, I'm going to go to edit order. I'm going to take this link and I'm going to move it down to just above accept request. So this link is what's transferring this information between the two. If I take this imagery data and move it up, if I change the order once more and take this imagery data down here and move it up to be right above accepts request, it'll be a little more so what's happening here is I'm taking a long time here on this link to send this message. And if I go back and look at imagery data in the model, I'm going to go back here and look at imagery data, and you'll see that imagery data is a 10 megabyte file. And so to go on a 250 kilobyte per second link, it's going to take a long time. So that's not really the performance I would like to have. So what I'll do is, if I go back into my model and I want to move this imagery data and have just a different bandwidth downlink for the satellite. So if I go back here, I'm going to look at that, sorry, I went to the wrong model. If I go back to my link model here, here's the item, and I'm going to look at the satellite communication, and it's the data, data imagery. This is the huge one, and so I'm going to remove it from here. I'm going to go to the transferred by relationship, and I'm going to look at the links that I have. I'm going to remove it from this one, and I'm going to add it to the satellite image downlink. And this link that I've already created in my model has a 10 megabyte a 10 megabyte per second transfer rate. So now that I've done that, just want to check one more thing here, make sure we're good to go. Go back to the link model. I can go back to my EFFBD that I had. You don't see that link here, but I know that this imagery data is on there. I'm going to look at the simulator again. Run it. And I should have kept track of how long the last one ran, but you'll see in a moment here, I'll have to open it up with both of the links. But you'll see now it looks much more compact. I'm not waiting on that link. And if I go to the database entities and look at the links, I've got both links here. And you'll see that this downlink now is only taking, duration of 6 seconds to get all the information down. So I have two separate links, one to allow me to have much better performance if I have this large bandwidth data link. Of course, in my engineering design, I have to go through and figure out, how am I going to do that data link and make some more requirements for that particular link as opposed to this link here. All right, so we have covered here a set of things we can do with the functional architecture. I'd like to go back to presentation here. We're going to now talk about the analytical architecture. So when we've got all of our descriptive architecture done on the left-hand side, or as we're in the process of doing this, many times we want to look at we want to look at, well, how do the physical equations that relate these components together, how are they coming together? What are those implications on my design? And many times we're doing this in a model in MATLAB or some other mathematical analysis tool to look at the equations, and we really want to be able to link these two models together. So one of the ways we do this is we look at constraint block diagrams. So constraint block diagrams show us, give us an idea of how the components in our architecture are constrained. In this case, I'm developing this element called the new vehicle, and it's going to be constrained by total weight. In other words, the designers have said the curb weight of the vehicle is going to be some number, and if I put a certain number of passengers in there and a certain amount of luggage, I'm going to come up with a total weight of the vehicle. And I don't want the vehicle weight to exceed, you know, some weight. Obviously, if as the weight goes up, I've got to put a bigger and bigger engine in it in order to make it go down the road. So I've got to constrain the overall design by weight. The other thing is I have a cross-sectional area constriction. In other words, as the vehicle gets larger and larger, as it gets higher and wider, I have to put a larger engine in it to just push it down the road to overcome air resistance. That makes sense. And so I have these two equations that relate weight and cross-sectional area. But how do those get calculated? And that's what a parametric block diagram does. A parametric diagram shows us how these things are related. In other words, over here, at the top of the right-hand side, I have the block for total vehicle weight. And so the different parameters for the number of passengers, the weight of the parameters, the weight of the luggage, etc., adds up to a total weight. Well, that total weight in turn is used by an equation for basic motion, right? So I have to know the mass of the vehicle, the design acceleration of the vehicle, and in the amount of time. So if I want the vehicle to go 0 to 60 in 5 seconds, and it's going to weigh 1,000 pounds, it's going to give me a basic force that I have to have, a linear driving force to get that vehicle down the road. So we can show all this in GENESYS. We can show all these diagrams. So I'm going to switch back to GENESYS here a moment. I'm going to close this diagram, and I'm going to go up here to components, and you'll see here, this is the new vehicle that I was talking about on the slides, and this is the constraint block definition diagram. So here's that constraint block definition diagram that I just showed you in the screen. So there is that diagram. Okay, I can expand this a little bit to show you the whole. Okay, so I have a height and a width of the vehicle, and so I can get a cross-sectional area and I can get this total vehicle weight. Okay, where those come from is I have this parameters tab here, and here's how I'm defining these elements. So I have an air density, I have acceleration time, I have an acceleration of the vehicle. But you'll note that in the diagram that I showed just a moment ago, the total vehicle weight is the constraint on the new vehicle, but these parameters are really assigned to other things. In other words, the curb weight would be assigned to the overall chassis of the vehicle. The luggage and the passengers would be part of the passenger compartment. So when I look at this, so these the parameters on height and width of the vehicle are coming from the vehicle frame also. So if I look at the vehicle frame here, you'll see that I've passed in from the requirements the length, the height, and the width of the vehicle, and the curb weight. Curb weight in vehicle design is the weight of an empty vehicle with all of the consumables, all a full tank of gas, all of the transmission fluid, and the oil and brake fluid and all that stuff. And if you look at the passenger compartment here, I have a maximum capacity for luggage, I have an average passenger weight, and then a total of 5 passengers in the vehicle. So that's how I get to understanding what the constraints are on the vehicle. Well, those constraints then can be shown in a parametric diagram. And what I do here is I actually define what the vehicle weight is, and I come up with an equation here that shows me the equation of how I'm going to calculate the total vehicle weight. And then I have simple algebraic terms. I have independent variables and dependent variables. Okay, so this is how I calculate total weight. And I talked about total weight being related to the force due to basic motion, and I'll show you that. And I'll open up that parametric diagram, similar to the one we just had on the screen. So here is that parametric diagram. So if I want to know the force due to basic motion that I need in my vehicle, I have to figure out all of these, what I will call input parameters, to figure out the total weight of the vehicle. Then that weight would be passed to this equation, and I have to add the design acceleration and a time and a conversion factor in order to figure out the total force. Okay, so with that in mind, let's go back to the, sorry, wrong model. Let's go back to this model here. And if I look at the project tab, you'll see a constraint solver, MATLAB constraint solver. So I can open up this. And what I'm going to do is I'm going to solve the selected constraint definition for force due to basic motion. There's various ways you can apply this constraint solver. I'll just keep that very basic one. And I'm going to pick up the force due to basic motion. And what the constraint solver does is it's really a link. It's really operating in the background. It's a link between MATLAB and GENESYS. And what it's doing is it's looking at the things that I've populated, the elements, the attributes I've populated here on the parameter page, on the constraint definition, excuse me, and it's picking up it's picking up it's picking up all of these all these parameters, excuse me, and it's going to do this calculation here. And if I go to the next slide, it's going to give me this new vehicle weight. Excuse me, let's keep going here. And so then if I finish, you'll see, oh, I missed. Let me go back up. I'll do the total vehicle weight one here. Probably simpler and easier to see. Go back through this again. Total vehicle weight. So here is the constraint solver. If I go to next, now I could save this off if I wanted to, just so I could look at it later. If I go next, execute the script. And what I didn't do a moment ago is it gives me a number, and then I can update the parameters. It'll tell me whether that's changed or not, okay? So I'm just going to finish here. Now, if I go into the vehicle frame, and I'm going to take this parameter here, and I'm going to change this parameter, the curb weight. I'm going to make this, let's say, 5,000. I radically increased the overall weight of the vehicle. And so then if I go back to my constraint definition, and I did total vehicle weight, and I run through the constraint solver again, again, it's looking at this. Now see how it's picking up this new value? The value right there, 5,000, is going to change. I'm going to go next, execute the script. And if I click update parameters, it'll say that this total weight has been changed. Well, that's interesting. The total weight has been changed, so I can finish here. And if you go back to the component here, the total weight was part of the vehicle frame. And if you look here, you will see that I had this weight now, and that weight was the weight I had just a moment ago. So I can actually go through and change parameters and see how the parameter changed. What if I change the weight to, if I minimize the weight to 2,000 pounds? What would that mean? And that weight might mean an implication on fuel tank, or maximum range at efficient speed. And all those equations can be determined. All those equations can be built up through various constraint diagrams. I believe this diagram here is total required driving force. Let's see how that looks. So the total required driving force on the vehicle, and I'm not going to go through and execute these, but just to show you how complicated this can get. The total required driving force is really a combination of the force you have to overcome force due to rolling resistance. You have to have the force due to basic motion. You have to have the force due to air resistance. So all those add up, and they're all dependent upon the cross-sectional area and the total weight of the vehicle. So as you change the weight and cross-sectional area, you can actually execute this to actually see how the total required driving force would change. So, so that is my brief explanation of how this constraint diagramming works, and how the parametric diagram works, and how we connected here through MATLAB. Now, although we have a connection here to MATLAB because I have a license of MATLAB, you can create through our open API a connection to any other sort of analytical model you have. So if you have a different analytical engine, you can create the mappings for how you pull in those equations and parameters from these attributes here in the on the constraint definition. All right. So I just want to wrap this up with a summary slide here, and then open us up to questions. So I've gone through the functional architecture and changing that to the behavioral architecture, showing us how we can check our design feasibility. Is that functional architecture feasible? Can I actually do it? I can use that to communicate to other stakeholders in the design team as to how I want the functionality to occur, why I sized the different links between different components the way I did, why I want messages to flow around in a particular way. I also showed the descriptive architecture. There's the component, the physical allocation or the physical breakdown of the components, the drivetrain, the new vehicle, etc., and then how our constraints constrain that design, and how those parametric equations build up so that we can look at the impact of changes in what's seemingly an insignificant requirement at the very beginning, how that requirement can actually multiply in its importance as the design goes on. And one thing you can do with that is when you show things like the parametric diagram, it gives an indication, or it helps to explain to people that are not non-engineering team members why a simple change in a very elementary, what appears to be a very elementary requirement, can really have ripple through the architecture and have a huge impact on that on the architecture. So Donna, I'm going to go to the last slide here, and I'm sure you've got questions out there. This is a lot of material and a lot of time in a very short period of time, but I just wanted to scratch the surface on how some of these things would occur and how it helps you understand and make sure you have a complete, consistent, producible architecture. So do we have any questions?
Yeah, thank you, Ron. We do have a few questions, thanks to all our participants. I do encourage you to join the discussion now and submit your questions using your webinar control panel. If you do need to leave the webinar, please take a moment before you go to respond to the quick survey that will pop up on your screen. Our first question is from Rachel, and she asks, on your constraint block definition diagram, there were some blocks that had a notch in the upper right-hand corner, a block in the upper right-hand corner. Why is that?
So let me go to the constraint block definition diagram. I think this is the one I was using. Views, constraint. So this was a diagram I had. Well, what that little, it's pretty easy to see on this one, but what this little black dot in the upper right-hand corner means is that this vehicle frame block is shown other places on the diagram. It's pretty easy to see by inspection that it's there, but if I select that block and I right-click, I can look at select matching nodes, so it'll highlight the different matching nodes. Now it's pretty simple to see here, but if we had a huge diagram, there might be 3 or 4 different places, and so this will show me where those places are. It's just an indicator that this block shows up on the diagram in other places, or this icon, I should say.
Okay. Our next question is from Dwayne, and this was on when you were running the simulation. He noted that the transcript at the bottom, is there a way that you can export that?
Sure. So we had a look at this. We fixed this earlier, right? So we have this EFFBD here. Show you the whole frame here. I'm going to run the simulator. So I have the simulator here, and this one's pretty small. I guess I really didn't need to expand it like that, but I can just save the transcript. It's going to save all this information down here, and you see this can get quite lengthy here. It gives me step by step everything the simulator did. And if I save the transcript here, I can save this transcript to CSV. I'll put it on my desktop. And then if I navigate to the desktop, I'll be able to find that right here. And can you see the CSV spreadsheet now, Donna?
Sorry, no, for me it's off the screen on the right-hand side.
It is. I don't know why that is like that. Let me see here if I do this. Does that bring it in?
Not for me, but that's okay, Will.
Okay. You go back to that. So is there another question?
Yes, there is. From Suja, if you have a MATLAB connector, or if you don't have a MATLAB connector on your machine, is there a way that you can export the script or do something to take it off?
Right, and so now I'm back in the model here. I'm going to switch back to the I'll go to the constraint definition, and I'll run that again. And when I do the constraint solver, and I'm just walking through what I already did. When I get here, I can save that as a file.
Okay, Ron, we're having some technical difficulties. I'm just seeing a blue screen.
I don't know how to change. Well, let me just explain it to you then. All you need to do is go to the next, when you get to the MATLAB constraint solver, as you go through, just click the save button. I had a warning come up that my screen was frozen for a moment, and then it released it. So I don't know how it.
You might need to stop sharing and reshare your screen.
There we go.
Yes, there we go.
Okay. So this is, so when I step through the constraint solver, when I get to this point, I can save that as now that's a .m file. So that's a file that I can take off my machine. I can save it, move it to a machine that has MATLAB, and actually execute that file. That's a MATLAB file.
Okay.
And if you maybe so this is what the spreadsheet looked like when I pulled all that information out.
Okay, and another question, do you need to have MATLAB licensed? Is that a separate license?
Yes. So we have a separate license for MATLAB. My machine has a MATLAB license assigned to it. So you do have to have a MATLAB license to get this constraint solver to work. So you do have to have a MATLAB license. And that's why, and that's the reason why we have that save feature, by the way, because you may only have 1 or 2 node-locked MATLAB licenses in your organization. It's not a license that you generally buy for everybody. So you can move that MATLAB script over to another machine to run it.
Okay. We do have a couple more questions. I'm going to pick and choose. We're getting really close to this hour mark. Mark asks, in your satellite functional architecture model, could you add the parametric equations using MATLAB modeling the effects of atmospherics on the transmission links in the execution of the EFFBD model, or is it a parametric model execution run?
So the effects of the atmospherics wouldn't be part of the EFFBD unless you knew that, you know, on a certain app you could change. Let me go back here. The model, the things that are used in execution of this, of the functional diagram, is the delay and the capacity numbers that are here. So that delay number is a number set through the numlock, through the number window, and so is this capacity. If you have a certain atmosphere that has a different transmission factor, if you will, and you know that the capacity and the delay is different, you could put those in and then run the model. Now you can do parametrics. You can do parametrics on the link, and you can do a parametrics on the items and the functions. So you could have a background parametric model for those. So I'm not. I don't know if I answered your question. I just tried to show you what the capabilities and limitations are of the system. Now, let me just extend that a little bit further, though. The reason we do this analysis here is to really give us a first order understanding of the constraints and limitations of the design. I think it's appropriate at some point to take a high level fidelity model, like a finite element analysis model or whatever, other model into MATLAB or whatever simulator you have, and run that simulation to help feed back what are the constraints on and what are the constraints on the basic system level design.
Okay. Thanks, Ron. That's going to wrap up our Q&A. If we didn't get to your questions, I do apologize. We will contact you directly to ensure that we've answered your question fully. Obviously, you can contact myself or Ron here at Vitech if you have further questions. You can also post your questions or comments on the LinkedIn group page. Just visit linkedin.com and search for Vitech Corporation. Thank you so much for attending today's webinar and hanging on while we went over our hour mark. Remember that at the conclusion of the webinar, a survey will open on your screen. Please take a moment to give us feedback on today's presentation or on what topics you'd like to see covered in future webinars. Once again, thank you for joining us and have a wonderful day.